take a look at a rhombus and the properties of a rhombus. Now, important thing to know is a rhombus is a type of parallelogram. It just has some slightly more specific properties. So a rhombus still has opposite sides that are parallel, still opposite sides that are congruent, angles that are congruent, consecutive angles that are supplementary, diagonals that bisect each other, and diagonal will make two congruent triangles. So those six properties of a parallelogram still exist for a rhombus. But in addition to that, we have three more properties: that the diagonals bisect the angles, right? Remember, bisect means cuts in half. That all sides are congruent. That's going to be a big one for you. And that the diagonals form right angles, which also is going to be a big one for you. So these three properties are in addition to those parallelogram properties from earlier on in the week. So let's take a look at a couple examples of what we might be looking at. So for instance, a rhombus has all sides congruent. It's a parallelogram that has every side that's the same length. What that really means for us is if the side length is 5, they're all 5. Right? They're all going to be equal to each other. Not just the opposites, all of them are equal to each other. So if we take a quick look at an example, it says in rhombus ABCD, they don't give us this rhombus, so we're going to draw a quick picture of a rhombus ABCD. It doesn't have to be perfect. A, B, C, and D. It tells us that AB is 5n plus 8, so 5n plus 8, and that BC is 3n plus 26. Now, what they want us to do is find that value of n. So these are not opposite sides, but because it's a rhombus, right, because the shape is a rhombus, we know all sides are equal. So we could take that 5n plus 8 and set it equal to the 3n plus 26. Right, and then we'll go ahead and we'll solve for that n. So we'll subtract the 3n from both sides. We end up with 2n plus 8 is equal to 26. Then we could subtract that 8 from both sides. We have 2n is equal to 18. And then when we divide both sides by 2, we end up with n is equal to 9. So we know that n is 9. So remember, all sides are congruent in a rhombus. Another, this is a very big property that does appear a lot, is that the diagonals are perpendicular to each other. Now, what that means that they're perpendicular is that they're forming right angles. And one of the biggest things you guys are going to probably see a bit with these rhombuses is that we're going to have these 4 right triangles. Now, the cool thing about these 4 right triangles is they are all equal to each other. But really, in particular, what we're going to focus on with these right triangles is that the Pythagorean theorem can be used. So if you guys don't remember the Pythagorean theorem, it's a squared plus b squared equals c squared. C is always the hypotenuse. So a lot of times what happens is we might know information about the 2 legs. So 3, like let's say one leg is 3, the other is 4. And we could use the Pythagorean theorem to be able to find what that hypotenuse is. So 3 squared plus 4 squared equals c squared. 9 plus 16. So we get 25 equals c squared. And when we take the square root of both sides, we end up with 5. So again, it's a way to find that side measurement. It's a very common practice. So quick example of this in rhombus ABCD. We have AE, which is 15, so this line segment right here is 15. BE is 8, this one is 8, and our job is to find the measure of angle AB. Now, we know that this is a right triangle because diagonals in a rhombus are perpendicular. So really what we're dealing with is just a right triangle where a side is 8, a side is 15, and we're trying to find that unknown side, right, that hypotenuse or C. So we could apply that Pythagorean theorem. 8 squared plus 15 squared is equal to c squared. And again, add them up, take the square root. But if you do know your Pythagorean triplets, we could just say c equals 17, right? 8 squared plus 15 squared is equal to 17 squared. If you don't know your triplets, just do the math out to check that one out. All right, the last specific property for a rhombus is that the diagonals bisect the opposite angle. So in the diagram, what we're seeing here is these 2 angles are congruent. These 2 angles are also congruent. Actually, all 4 of them are congruent to each other. And then the same thing on these 2 sides here. Those diagonals are cutting those angles in half. So a quick example for us, it says in rhombus ABCD, measure of angle 1 is 3x plus 9. That's this guy right here. 3x minus 9, excuse me. That's that guy right there. Angle 2 is x plus 19, x plus 19. And we want to find the measure of angle A. Now, if we notice, these two angles together form angle A. So what we have to do is find x first. Now, since we know the diagonals bisect each other, they're cutting, bisect the angles, they're cutting that angle in half. That means x plus 19 is equal to my 3x minus 9. So as we solve for x, right, we subtract x from both sides. We get 19 is equal to 2x minus 9. I'll add that 9 to both sides. I get 28 is equal to 2x, or x equals 14. Now, that's not my final answer. I need to find angle A. Angle A is the sum of those two parts. Now, we know those two parts are equal to each other, so what I'm going to do is I'm going to find the measure of angle 2, because that one's a little bit easier to work with, which is 14 plus 19. Right? When I add those two together, I get 33. Now, that's just this half of the angle, so the other half has to also be 33, which makes angle A, the entire angle, equal to 66 degrees. And that's our final answer. That's what we're looking for here. Measure of angle A is equal to 66 degrees. All right, so try a couple of the practice problems on the back and let me know how it's going.